Welcome to this video tutorial. Today our topic is about STATCOM implementation, and we will also incorporate the renewable energies. So here is the topic for our work, and here are other details for this topic, or you can say these are all topics are related to our work today. Here are specification. So here you can see that we have IEEE 33 bus system here, and we have connect solar, wind, and STATCOM model to this network at bus number 22. So let me mention, here is PV model, and here is STATCOM model, here is wind turbine. So let's get started. Fault is also placed here to just to compare results with fault and without fault. This fault can also be removed easily if we remove these lines. So here is details for slack bus. Just open it up. Here we have 11,000 voltages, and we have 50 Hz frequency. So our system main scope is here. At this point, just open it up. So here we have a, so let me run the program. So it's just compiling. There will be no issue in this Simulink model, no warning. So just a moment. It's a very heavy project, so takes some time for system to load it. So here we have, I just run the Simulink, and then I just stop it by clicking on pause button. So now we have values for our voltage, current, and power. So here are further details for voltage and current monitoring. Here is the mux, and here are all the inputs you can see here. And then here we have our PV panel of 400 kVAR. You can also say it 0.4 megawatt. We have 4 PV arrays, each of 100 kVAR. So here we have control, and here we have grid voltages. These are sinusoidal. So open it up. So here we have 400 kVAR, and then next we have our wind turbine. Let's open it up. Its size is also mentioned in specification, and here we have STATCOM model ABC. Just open it up. We have plus minus 3 MVAR, its size of STATCOM, and here is controller parameters. Let's open it up. Here are further details, and here are the final details for our STATCOM model. So STATCOM here is our main item, which have to perform the power quality, which have to improve the power quality during the fault and without fault. So here we have details for fault. Just open it up. So here we have 0.25 to 0.45 duration of fault. So in this duration we have fault occur. So later on in final stage, when we have to check the our system output, then we can easily monitor the fault occurrence from these graphs. So now here we have PV details. Here we have irradiance, which is taken as constant here, and here we have VI for grid. There is a problem in system performance. So finally we have to open this model. So here is grid BI details. So here is our final step to find the load flow. Just open it up, and then we have tools, and here we have load flow. Just click on it, and it is going to compute. It's loading. Just a moment. So finally there is a problem in the system. We have all the details here, so then you have to just click on compute, and later on you will find all the results, and then you have to click on apply to model. So that's all, and here is our main scope from which we can see the results for all. So thanks for watching.